Welcome to Changelog and Friends, a weekly talk show about HATEOAS haters. Thank you to our longtime partners for helping us bring you awesome developer pods each and every week. Fastly.com, Fly.io, and TypeSense.org. Okay, let's talk. So I am here with my friend Chris Brando. Hey, welcome back, dude.
Hey, glad to be back.
People enjoyed our last episode together.
Yeah, I saw that.
Do I sound surprised? You're like, wait, were they not supposed to? Or what were you expecting?
People generally like what I have to say, Jared. Come on now.
I was one of those people who enjoyed it. So, of course, happy to have you back. I think you enjoyed a recent episode I did with Justin Searles, at least the premise of it being this whole "it depends." That resonated with listeners as well. Maybe not the particular episode. Sorry, Justin. No, it did. But the idea that I had for this "It Depends" podcast and how we're just kind of doing it now loosely underneath the umbrella of Changelog and Friends, I think people like that whole idea of like two people with experience, different experiences, hopefully, diving into the nitty-gritty decision-making processes that we go through, how, question each other, etc. And you like that idea.
Yeah. I thought that, like, as soon as I heard it, I was like, oh no, this is a great idea, and this is definitely a show I want to be a part of, or like a mini series or whatever it is that I want to be a part of, because I do say it depends a lot.
You do. In fact, we put together that little montage of everybody saying it depends throughout most recent 50 episodes or so, and I think you got on there twice. You were the one was "it depends what TikTok you're on," which I'm not even sure what that conversation was about.
I guess it depends on which TikTok you're on.
I do have a soundbite of you. Maybe I'll put it in right here.
This episode is wild.
Where you say, "This episode's wild." And I think it might have been, I remember clipping that and saying, like, that's a good soundboard. Chris saying that. But I think that might have been the episode when you're like just talking about, it depends on what TikTok you're on.
Yeah, I'm trying to remember what the context that was. I remember saying it. I vaguely remember the episode, but I don't remember the context. But I also remember just like I was walking and I was listening, and then you had that clip of all the sounds, and I was like, "Oh, this is cool." I was like, "Oh, I wonder if I'm going to be in this, right?" And then I was like waiting, and then I heard that one of like, "Oh, it depends on what TikTok you're on," and I'm like, "Oh, really? Is that my "it depends" clip?" It's like that's the one. Like, I was like so disappointed, and then I was walking, and I think I like might have paused right before because I was like almost to my destination. But I like messaged you and I was like, I'm like so sad that this is like the one I had. And then I got to the end and then it was just like me going like, "It depends." Ugh. And I was like, oh no, that's perfect.
Yes. Which is why I use it as the closer, because just the amount of remorse and angst that you expressed there. In fact, one of those sounds was Matt Ryer saying, "I think "It Depends" should have its own little theme song." I didn't have Breakmaster put together something special yet. I'm just kind of riffing, but I did put together a brief jingle, and you may find your voice on it. Here it is.
It depends.
There you go. So I think that's a good representation of this whole concept.
Yeah, I definitely think so.
So Justin and I were talking about dependencies, and certainly a big topic, one that we will take up again, probably in different ways with different people over time, because it's one of those decisions that we all have to make on a recurring basis. And so it just requires a lot of thought and a lot of discussion. And I think a lot of data points is useful. Today, you and I are going to do an "It Depends" on APIs, which again, even that, as I say the term, is like a multitude of conversations could come out of such a thing. We're going to talk about designing APIs, building them. Also, we'll reference consuming them, of course, and all the little things. And we're going to start that conversation by "it depending" the jargon, because not all APIs, because even API is such a generic thing, an application programming interface that can manifest itself in so many different ways. And so maybe we start with a definition, or start that by breaking down kind of generically, at least, the major types of APIs that we come across.
Yeah. So like when I was thinking about this, I was like, okay, what kind of APIs exist out there? I think the one that kind of shoots to at the top of everybody's mind when they hear API are like web APIs or like microservice APIs, things that are like, typically built with HTTP and used to like communicate between separate computing entities. There's also language APIs, which we, all use, standard language, a lot of standard libraries, and, all of the dependencies that you import that have their own APIs that you're using directly in your source code.
Right.
But I also, there's like two other types of APIs that I think are also quite interesting. And I also think they kind of maybe can teach us a bit about how we should think about designing APIs. I think those are like the operating system level APIs, so like the system call library level stuff, like the the Linux system call standard library. I don't even know what to really call it, but yeah, like that layer of like really low level, really invoking from C or assembly or something like that. And then kind of even lower level are these things called ABIs, which stands for Application Binary Interface, which is like APIs, but for your, ELF or Mach 0 or Mach O, not Mach 0, Mach O, PE, like the format Windows uses, like how you can make sure that if you have a DLL that's compiled and, an application are compiled two different versions of the compiler, that they'll be able to work together. So it's kind of lower level, like machine code interfacing.
Right.
Weird stuff like calling conventions in there as well, which, I have a thing that we can get to later on about maybe how we can design APIs better there. The big two that people think about are definitely language APIs and then the web APIs.
Well, let's start with the language APIs or the programming level APIs. I think the web APIs is the one that most of us think of most of the time and probably consume as working developers. I think we probably are more consuming those than writing those. Surely we're writing them as well. But what we're all writing is like in the small APIs that we ourselves are consuming in our application code or in our library code, or that we're writing for others to consume in their application code. Literally all developers are writing those APIs. We don't really think about them, and we think about like functions or methods, or pick your particular term depending on the context of the executable. But we design those APIs all day, every day, don't we? I mean, we just don't think about it very much. But those, I'm sure you think that that should be designed, right? Not just kind of grown.
Yeah, absolutely. I think, I think this is like a big it depends area as well of like, what stage are you in, right? If you're just prototyping, like, maybe you don't need to do that much design or that much documentation of the API you're building. But definitely even if you're building, a whole cohesive thing that's just like a thing that's going to run like a CLI that's not going to be used as a library, still just, thinking through how you lay out your functions and your methods and your types and all of that, how those things interact is very important for like kind of the long-term maintainability of that API. And I think for most of us, when we're sitting down and writing all those things, we're just like, I just need a function that does this, or like this function's too big, so I'm going to start breaking it out into other things and kind of making more surface area of that API.
Right.
In a way, I'm not sure people would really do if they were thinking of this more as from the library sense. I think when you jump to the library design, you're like, oh, I got to really think about all of the functions I have and what they're doing.
Yeah, you think about it more because you think somebody else is going to be using this and it needs to be consumable and repeatable, or it has to have certain characteristics that make it good for them. But when we're writing our own functions internally that maybe nobody's ever going to see, or maybe you're going to use it once, a lot of times I'll abstract a function simply to put a name on the logic, and it's like, does that name needs to be relatively good enough to be descriptive so that I know what that bit of code is doing, but I'm not really thinking about it as an API because I'm just extracting a function so that I can name some bit of code. But when you're naming functions and designing functions, whether you're going to be using them, your team, your immediate team, or once you get to the library level, do you have heuristics or thoughts on like what makes, in the small, like a single function API, good or bad, better or worse?
Yeah. But I think definitely the number one indicator is how many parameters do you have, really? That's like kind of the first thing I always look at is like, does this thing have like 2 or 3 parameters, which I'm like, oh, okay, cool. Or does it, I think one of the code bases working on, we had this function that had like 16 parameters, and we're like, okay, well, this is a sign that this thing's kind of broken. And also like the number of parameters compared to the lines of code of the actual function itself, like The one that had 16 parameters was also like 3 lines of code because it was calling another thing that had 15 parameters. And that was a sign of like, oh, this is a spot in like our local API that we need to fix because this is just not okay. So I think like definitely looking at the parameters and the inputs to the functions I'm creating is one of the biggest signs that I tend to look at.
Yeah, inputs and outputs. I mean, I guess the 3 things that I consider is like the name, which if you're having a really hard time naming something, I think that's a point to slow down and maybe think you're trying to encapsulate too much sometimes. And maybe you're actually, it's 2 things or more, and that's why it's hard to name. But clarity and naming is something that I take very seriously, even with my own code, which there's lots of with my own code that I don't take seriously at all. but naming with clarity is one of them. Probably because code comments is not something I take seriously, and so I need good names. But naming inputs and outputs, right? Like that's pretty much what you're going to see from the outside of a function. That's what you're going to care about is like, okay, what's coming in, what's coming out. And I agree with you that like too many parameters is a indicator of, again, poor design or trying to do too much, or sometimes just scope creep, right? Because a lot of those functions start with not very many parameters, and then you're like, I'm just going to slap another one on at the end here.
Right.
And that's fine. And it probably was. And then the next time you come back, you're like, I'm just going to slap another one on at the end here. And at a certain point, you get to 16, right? And then people have meetings about your function that you wrote, and that's a problem. Then there's the cheat code, right? Which is where you pass in a hash or a map or a struct, right? And you're like, see, it only takes one input.
It only takes one. Yeah, that's one of the things that when Go introduced the context object, there was a lot of push in the community to be like, don't put random junk in here. That's supposed to be a parameter. Like, don't do parameter hiding in this thing because that'll allow you to pass too much stuff into a function and not really rethink if this function needs to be broken up or if you need to start restructuring your code. Because that's one of the things I really love about Go is that because things are pushed to be so simple in a lot of ways, it becomes much easier to see when there's a problem somewhere. Whereas if you have that, kind of bag of stuff you can pass into something, it can be a little bit more difficult or challenging to figure out like what stuff is in here, what am I actually getting, what am I actually using.
Exactly. I find a lot of complicated, what's the opposite of confident? I mean, non-confident. Let's just go with that. Non-confident code is like dealing with what bag of stuff is in this particular, like what are the contents of this bag of stuff? And I know that my TypeScript friends are yelling right now, that's what TypeScript is for. But I'm sure you can pass some sort of an object in there and not define the contents of the object if you don't want to and end up with a bag of tricks. But the any type, that's the one, right?
Yeah.
In Go, it's pretty persnickety about that, but I'm sure you could just pass a struct in, like the context object, right?
Yeah, you can pass and that does happen quite a bit with APIs where you have like a struct, especially when it's like a constructor where you're like, oh, there's a lot of different things that might be in here. You have a struct or like a special object type that builds up options and you pass that in. There's definitely cleaner ways to pass a large amount of information in. But it's also sort of obvious when you're kind of looking at it. And sometimes, at the end of the day, you do just need to pass a lot of parameters into something. And I think when you do like kind of bundle it into a struct, into another type, I think that's pretty okay. As long as you've like thought about it, as long as you can like name that type properly and it's not just kind of like input to function name or whatever.
Right. Or data. That's what I go with when I can't think of a better name. It's like, here comes the data, I mean, Context is kind of just as bad. I mean, context is a pretty meaningless thing once you start to think about it. Like everything is contextual, right? It's all context.
I mean, we've done a pretty good job of making sure that the context object just contains oddly like timeouts and then like some really like at the end of the day contextual objects for like, okay, well, like this provides you information about the environment around you so that you can more properly do something within the function. I rarely put things into the context object. It's mostly just I use it for timeouts and cancellation, which is the I think main reason why you're supposed to use that object. But I know in like other languages, like I remember when I was still writing PHP back in the day, there would be a lot of like I don't remember what it's called, but you kind of inject everything down. So you'd have this nice big bag of stuff. And you just pull whatever objects you need off of that and then use them. And I just remember like how much of a mess that could be and how confusing it could be to like trace where all of that came from.
Well, so in Phoenix Land in Elixir, we have the connection. That's like your web request, your singular request that's flowing through all code. And we use words like pipeline. So like basically, and it's immutable. So that helps out. You can't just change the connection itself, but you can return a new connection, of course, with different properties. And doggone it, sometimes, here's an it depends. I mean, sometimes when I'm just wanting to pass something else to myself later down the pipeline, like that whole deal, like, I'll just throw it on the connection and, I'll check if it's there later. And if it is, then I'll just do something with it. And it's like, I know that there's a better way, and yet so darn convenient and like used sparingly. It's very productive to just, add a little bit of context in your land. But
yeah, I think that it's definitely it depends sort of thing there too, where I think the goal is to always try and make your, parameters and your function signatures really clean and pristine and nice. But like sometimes you just can't get there yet. And sometimes you do just need to make it messy, and then you'll figure out how to clean it up later after you've kind of gone through the process and better understand the structure of things. Or sometimes, stuff is just messy. Like everything doesn't have to be clean and pristine. You gotta balance the amount of time you spend thinking and designing something versus actually implementing and getting stuff done.
Yeah, sometimes when I find myself very stuck, especially with like a name or how do I frame this situation, that's when I just realize that I'm lacking some sort of information that I'll probably have later, which is like just more knowledge about what I'm trying to do and how it's going to work. And so I will slap the worst situation on and like a bad name.
Right.
That's when I'll use code comments, right? And I'll be like, this name is terrible. I couldn't think of a better one. Please think of something better. And then I'll come back to it and be like, oh, that name is terrible. Now it makes sense that it's this name or it's this parameter. And so, yeah, sometimes you do just have to move forward. But I guess then it becomes, are you actually going to be diligent when you return to that? Or are you also in a hurry at that point and just like, I can't rename this now. I'm too busy. And then it just stays a mess. At some point you do, when you have the information, go back and change that. So that's thinking obviously in the very small. What about at the library level API design? I mean, some things that I really appreciate in library APIs is guessability. I don't know what the word is, where it's like it's named and it's used in the way that I would expect it to be.
I think that's like consistency.
Yeah, consistency plays into that. Principle of least astonishment plays into that. I think uniform access principle plays into that sometimes. But it's really just like, if it works the way that I thought it should, then I feel like this is a good library. Maybe that's just like Jared bias. Like you probably use some software where you're like, you can darn near just know the way it's going to work. I mean, I feel like jQuery was like this very much, where you could be like, I bet there's a function called like dot upcase. And then there is one. That's not jQuery, doesn't have that. But for instance, like I bet I can just upcase with dot upcase. And it's like, oh, cool, I totally can. And I feel like there's something good about that. Or is that just very subjective?
I feel like this is one of the things I really liked about Drupal when I was, writing that in my early career, is that there was this hook system, which like for a lot of reasons, it wasn't a great system, but it made it very predictable to know like, oh, if I want to inject this piece of functionality, I know the words I should write in the order I should write them to actually affect that piece of functionality in the way that I want. It's like, oh, I want to modify this thing before it gets processed by this module. Oh, I know I can write this function with this particular name and it'll get processed before this. And that predictability, that ease, that consistency made it kind of really elegant to work with that system. There are all sorts of problems with that hook system, right? If you made a typo, it just wouldn't run your code. You have no idea why. And you're like, well, what's wrong? It's like, oh, there's a typo in here. So there were many reasons why that system was not great, but I did like the elegance of that. And I feel like that's also one of the things that pulled me into Go when I was making that transition. I was making a decision basically between Go and Node.js, and I went with Go. And part of it was because when I was writing code, there was just this ease of predictability of like, what should this thing be called and that I want to call? And you just type it out and it'd be like, oh, it's that thing. It's like, oh, yeah, I need a buffer of bytes. You're like, oh, bytes.buffer. It's like, oh, that's a thing. Or like, oh, I want a reader on this like slice of bytes. Oh, bytes.reader. Like there's all these like nice little things that made us like, oh, okay, this just makes sense. It just flows together well.
Yeah.
And when I've subsequently tried to design APIs, I try to do that as well as just making everything consistent and predictable as much as I can.
And that's one of the reasons why I really did not enjoy PHP as a language when I used it, was because, and this is ancient history also, I know that PHP is way better now, but the language design was so inconsistent that like the functions, the way that you work with arrays versus strings versus these things, like I was constantly referencing the docs because I couldn't possibly remember the way in which you would do the same thing in this particular area of PHP that you would in the other particular area. Whereas Ruby, which is what I went from Perl. So generally speaking, I went from Perl to PHP to Ruby and to Elixir as like primary languages in my life. And I've done a lot of other ones as well on the side. But when I found Ruby, the consistency of like the string objects, functions, and then like the way their arrays work, and the way that hashes work, and the way that they're like so consistent throughout, that I just felt like that was so much more enjoyable to use because I wasn't stopping and saying, wait, is it stir underscore len this time? Or is there no underscore, for instance?
Yeah.
And so, yeah, that consistency, and which turns into, I guess, guessability, is important. I think there's an amazing rant called PHP, A Fractal of Bad Design.
I'm pretty sure I've read that.
Written by, I can't remember who wrote it, but just a complete takedown. This is, again, it's probably 15 years ago now, of PHP just as the language design. It has a lot of good properties as an overall language and ecosystem, but we're talking about specifically API. It's so inconsistent that I found it frustrating. And at first I didn't really know, because Perl is kind of like that as well. Perl has like short and long versions of everything because of the whole golfing angle to their community, which I think is really cool, but cranks out some of the most unreadable code in history because of all of the special characters and short versions of everything. But I didn't realize there was like better ground out there when I first started using PHP inside of WordPress until I came across Ruby. And I was like, oh, this is what a good language would look like. Just as API design specifically. Ruby has its own warts as well, of course.
Right, yeah.
And I find Go to be very easy to read and straightforward and small in the same way where it's like, it is, I think, consistent for the most part in my limited use of Go, which I've written a few Go programs, but not many.
Yeah, I mean, that's the thing of those relates is just like the very strong adherence to the idea of like simplicity, and through that simplicity having clarity. Like that's always what I've kind of looked for in the programming languages that I've used. And it's kind of like, I think part of the reason why I like just did gravitate toward Go over like, so I was writing Ruby for a little bit of time. I was writing JavaScript and spent a lot of time writing PHP, and like all of those languages just, they didn't have that simplicity that I was really craving, that ability to just kind of sit down and just kind of write some code and have it be kind of like what I saw in my mind would be like what is actually in the document at the end of the day. But I realize that's also kind of like a weird brain thing for me, because I think a lot of people, like for them, like Python or Ruby or PHP, that's their language that they can do that in. But for me, it was definitely Go for a long time. I'm trying to like explore other things now. I'm getting like back into JavaScript and finding there's some things that I like, maybe controversially around like, oh, like not having static typing is freeing in some ways, even if it is a little annoying at times, like, being able to kind of opt into a little bit of static typing when you want and having it be more on the dynamic side.
Right. So are you working solo though?
Yes. So right now it's just me solo. So I realize that that's also just a different type of experience then.
I eat, sleep, and breathe dynamic languages. Always have. And I've used, Go bugged me in certain ways. I think the type inference was way nicer than things that came before it. And I still get just annoyed at types. And so I'm very much not on the type side, and I even told you this in chat because we're talking about typing as it depends. And I think that's a good topic for it depends. I don't like them, but I'm not a person who argues against it because I literally work by myself most of the time.
Right. On
small projects most of the time, and small teams all the time. I mean, the largest team I've worked on is like 5 people, and the code base was long lasting. So that changes things as well. But that's probably like the biggest team I've been on. And so I don't feel like the person who should argue these things because I live in like this weird world that most developers don't. And so that's why I asked, are you solo? Because I agree with you 100%, but I wonder if you would have that same feeling working with a whole bunch of people moving fast and breaking things.
I think so, because I'm someone that's going to push very hard in every code base I'm in to make sure it's like well documented and well thought out. And what I've seen a lot over the course of my career is that people will not do good design of their code and use static typing to paper over that. So like the static typing that they have allows them to be a little bit worse. So they are a little bit worse with the actual documenting of their code and the actual thinking of how their code works. Whereas if you're in a dynamically typed language and you try and do that same stuff, you just won't be able to function, right? Where there's some code bases I've walked into and it's like, I can barely understand this because there's types, but that's because you also haven't documented anything and everything is named terribly, mostly because you can.
Like it's a crutch.
Yeah. And the spaces and the code bases I've walked into, one of the things I try to do is like, okay, I'm going to try and document this. I'm going to sit down and figure this out and then write things about it so that we can all understand the page that we're on. Also, the benefits that people get from static typing isn't really the static types. It's the compiler being able to tell them, hey, you've probably done something wrong here, which doesn't actually require declarative types. It just requires I think there's a language called Rock that you don't declare any of the types. It does type inference for everything. And like that's the type of thing I think people actually want at the end of the day, which you can get from dynamically typed languages, because at the end of the day, like dynamically typed languages do have typing. They're not assembly, which has no typing.
Right.
The typing just tends to happen at runtime, but that doesn't necessarily mean you can't do it statically at static analysis at compile time.
Well, here we are talking about types. Let's reroute.
It's a different episode.
It's an entirely different conversation, and one that I'm sure our good friend Nick Nisi will want to be a part of as the TypeScript fanboy of our changelog community.
What's up, friends? This episode is brought to you by our friends at Neon. Serverless Postgres is exciting, and we're excited. And I'm here with Nikita Shemganov, co-founder and CEO of Neon. So, Nikita, one thing I'm a firm believer in is when you make a product, give them what they want. And one thing I know is developers want Postgres, they want it managed, and they want it serverless. So you're on the front lines. Tell me what you're hearing from developers. What are you hearing from developers about Postgres managed and being serverless?
So what we hear from developers is the first part resonates absolutely. They want Postgres, they want it managed. The serverless bit is 100% resonating with what people want. They sometimes are skeptical, like, is my workload going to run well on your serverless offering? Are you going to charge me 10 times as much for serverless that I'm getting for provision? Those are like the skepticism that we're seeing, and then people are trying and they're seeing the bill arriving at the end of the month and like, whoa, this is strictly better. The other thing that is resonating incredibly well is participating in the software development lifecycle. What that means is you use databases in two modes. One mode is you're running your app, and the other mode is you're building your app. And then you go and switch between the two all the time because you're deploying all the time. And there is a specific, part when you just like building out your application from 0 to 1, and then you push the application into production, and then you keep iterating on the application. What databases on Amazon, such as RDS and Aurora and other hyperscalers, are pretty good at is running the app. They've been at it for a while. They've learned how to be reliable over time, and they run massive fleets right now, like Aurora and RDS run massive fleets of databases. So they're pretty good at it. Now, they're not serverless, at least they're not serverless by default. Aurora has a serverless offering. It doesn't scale to 0, Neon does, but that's really the difference. But they have no say in the software development lifecycle. So when you think about what a modern deploy to production looks like, it's typically some sort of tie-in into GitHub, right? You're creating a branch, and then you developing your feature, and then you send in a PR. And then that goes through a pipeline, and then you run GitHub Actions, or you run in GitLab for CI/CD, and eventually this whole thing drops into a deploy into production. So databases are terrible at this today. And Neon is charging full speed into participating in the software development lifecycle world. What that looks like is Neon supports branches. So that's the enabling feature. Git supports branches, Neon supports branches. Internally, because we built Neon, we built our own proprietary, and what I mean by proprietary is built in-house. The technology is actually open source, but it's built in-house to support copy and write branching for the Postgres database. And we run and manage that storage subsystem ourselves in the cloud. Anybody can read it. It's all on GitHub under Neon database repo, and it's quite popular. There are like over 10,000 stars on it and stuff like that. This is the enabling technology. It supports branches. The moment it supports branches, it's trivial to take your production environment and clone it, and now you have a developer environment. And because it's serverless, you're not cloning something that costs you a lot of money and imagining for a second that every developer cloned something that costs you a lot of money in a large team. That is unthinkable, right? Because you will have 100 copies of a very expensive production database. But because it is copy and write and compute is scalable, so now 100 copies that you're not using, you're only using them for development, they actually don't cost you that much. And so now you can arrive into the world where your database participates in the software development lifecycle, and every developer can have a copy of your production environment for their testing, for their feature development. We're getting a lot of feature requests, by the way, there. People want to merge this data or at least schema back into production. People want to mask PII data. People want to reset branches to a particular point in time of the parent branch or the production branch, or the current point in time, like against the head of that branch. And we're super excited about this. We're super excited. We're super optimistic. All our top customers use branches every day. I think it's what makes Neon modern. It turns a database into a URL, and it turns that URL to a similar URL to that of GitHub. You can send this URL to a friend, you can branch it, you can create a preview environment, you can have dev test staging, and you live in this iterative mode of building applications.
Okay, go to neon.tech to learn more and get started. Get on-demand scalability, bottomless storage, and data branching. One more time, that's neon.tech.
Back to APIs. Let's get off languages because we could probably live here the whole day. It's definitely, to me, a fascinating conversation, but I think, most of the time when we talk about APIs, we are thinking about like that proper noun, right? Like a third-party API or a web service API or a microservice API. And so we are designing these things, we are using these things, and there's a lot of questions you have to ask yourself when you're creating one. One such question is like, well, what kind of API do I want to write? That's like, I think where you'd start, isn't it? I don't know. Where do you start, Chris?
Yeah, I mean, I guess when I'm trying to write these things, I'm thinking, what is the thing that I'm trying to accomplish? Like, what is the shape of it, right? Is this a request response sort of thing that I'm trying to make a API around? Or is this like a one-way feed of information? So is it like an event stream that I'm trying to get access to? And even within the event, like the request response, is it like a immediate processing? Is it a long pole processing? Is it like a send a thing, it sends me an accepted back, and then I wait a while, and then I go and fetch the result later. So I start to that's usually where I start thinking of like, what's the shape of this? And then from there, I'll go in and be like, okay, well, what technologies can I use that will be advantageous for this shape? Or if I'm like working with others, it's like, what are we already using? Usually is that's where you start. It's like, what are the things that are already in usage? Will those things fit the need that I currently have? And if they will, then I'll use them. If they sort of do, okay, we'll probably try and use it. And if they don't, okay, well, now we have to have like the discussion of like, well, what's the thing that will actually fit better?
So you don't just use GraphQL every time?
I never use GraphQL.
I never use GraphQL. Okay, well, we might plumb those depths. I also never use GraphQL, but not necessarily for any reason other than I've never had a reason to use GraphQL. I thought about it once. with changelog.com because there's a tool called, I think it's called PostGraphile or PostGraphQL. And this is when GraphQL first came out. And of course, we did a show on it. And after any show about a new technology, I'm nerded out, right? And I'm like, oh, this is cool. I should probably go try this. And like 99 out of 100 times, I don't actually go try it, but I have good intentions to do so. And with GraphQL, I thought, well, we have a website that renders HTML. It does not have a proper API for people to consume. Maybe we could put out an API of changelog.com, which has people and topics and episodes and all these like typical things that might be interesting, news items, etc. And maybe I'll do a GraphQL API for that. That'd be like a cool thing that people might want to play with, because one of the things I think is cool about GraphQL as a front ender who's like building a thing in the browser is like you can really just play with it and find stuff and do stuff. And it's very enabling, I think, for front end devs, which I think is a powerful property. But then I found this tool, PostGraphQL, I think it was called then. I maybe renamed PostGraphile, and it's going to take your Postgres database and turn it into a GraphQL API, which is kind of a cool idea, but also kind of like, are you just basically exposing your database to the world? You know, like sort of like that. And I used it one time, and this was, again, probably a decade ago, so I'm not going to speak on the current product or anything like that. I think it was a cool piece of software. And it sure did. It just was like, yep, I didn't ship this, but I played with it. And I'm like, yep, basically you could just turn your entire, but I don't want to just turn my database into an API.
Right.
Like that's not designed.
No.
So no, it's not. It's just like here, SQL over the wire, roughly speaking. And I'm sure there was different things that you could do. The reason why it really fell apart for me was I wanted to have some sort of other place where I would define rules and like things. And the way that PostGraphile worked back then was like you literally had to define everything in your Postgres database, including like access controls and a lot of stuff that I just didn't have at that layer.
Oh, yeah.
Like row level constraints and blah, blah, blah. And I'm like, I don't go that deep on my database. Like I put that code generally in my app logic. Anyways, I stopped there. That's the closest I ever got. And I haven't really considered it since. But why don't you ever use GraphQL?
So I think historically it's been mostly because I've been in the like REST camp for a very long time. Like, I mean, this is a while ago. This is almost a decade ago. But I basically accidentally bought, I think it was called like RESTful Web Services or something. It was a book when I was starting to get into like HTTP APIs. And it happened to be a book about hypermedia that I didn't even realize. And I was just like, oh, this is pretty cool. I really like this stuff. And then I sat down and I read Roy Fielding's paper, his dissertation on REST. And I was like, oh, this makes a lot of sense, and then got really into HTTP and learning a lot about how HTTP works and the mechanics of it and all of the different things you can do with it. And then I think for just a while when I looked at GraphQL, I was just like, I would be more inclined to use this if you didn't put it over HTTP. I'm like, this is just an improper usage of HTTP in a lot of ways, or just like I don't know if it's improper, but an unfortunate usage of HTTP. And when I started looking at the arguments for why we should use GraphQL instead of, say, a hypermedia API, I just found those arguments to be incorrect, or just like people didn't quite understand what hypermedia APIs were. And so they were making arguments that didn't actually align with what the reality was. And once again, like if they had just said, I just want to do it this way because this is how it makes sense to me, but I'm like, okay, cool, fine, maybe I'll try this thing out. But because they had framed it as this like, oh, hypermedia APIs can't do this thing, and this is why you need GraphQL, I was just like, well, no, you're wrong. And now, because I'm in this camp, you're silly, so I'm not going to use your thing. Which is like, the tribalism thing that tends to happen.
Yeah.
Recently, like a few months ago, tried to sit down and read a book about GraphQL because I was like, okay, I want to give this thing a real shot. And I just put the book down after like the first chapter because I was reading it. It was trying to give this history of HTTP and REST APIs. It was just like completely wrong. And I was like, well, I guess if this is like, and this is like a book from O'Reilly. So I'm like, if this is the way that this community is still behaving, like I can't do this right now.
Right.
So that's like the main reason why I just like kind of gravitated away from GraphQL, because it just like, it didn't make sense to me as something that should exist in the way it does, given what you can do with HTTP. I feel similarly about gRPC, and I'm kind of like, I don't really understand why this exists, given what you can already do with HTTP.
Well, GraphQL is over HTTP, right? But is gRPC, is that just a TCP connection? Or
No,
is
that's over HTTP 2.
Oh, it is?
Yeah.
As well, or version 2?
No, I think gRPC is exclusively okay. Well, gRPC is interesting because technically you can put it over pretty much any transport, but the default transport is HTTP2.
Gotcha. I think GraphQL was an example of technology that was built to serve the needs of Facebook.
Yeah.
That most people don't have, but also demoed really well and appealed to front-end developers, of which there are many. And it does provide them some freedom and flexibility and empowerment that other technologies do not. And so that combination, I think, was what led to its rise with those two things.
Yeah, I definitely agree with that. I think like from the perspective of a front-end person, I think GraphQL makes a lot of sense. Or the perspective, I think gRPC makes a lot of sense from the perspective of somebody that's just like, I just need to get this thing working. Like I understand why they exist, and I kind of support them in that way too. I'm like, hey, if this gets you to build the thing you're trying to build, great. But definitely from the back-end person perspective or from like the design perspective, I'm like, if you're actually sitting down to design this thing and you really want to think through what you're doing, they don't feel like the tools to do that. And I've tried with gRPC, and I just, especially with like the fact that so much of it's built on top of protocol buffers, and I'm like, this feels awkward. And then you have to manage protocol buffers. And if you don't have a way of managing them, then it's just like, okay, well, now this is just a whole other mess you got to deal with. And there's some other underlying things that when I sat down to try and do it, when I was at a company that was actively using gRPC and like kind of my job to evaluate these things and evolve them forward, I was just like, I'm having to modify gRPC so heavily just to kind of get the things that I want. And I just wound up falling back to like, let's just use regular HTTP here. Let's just build on top of these building blocks that we already have access to.
So generally speaking, you think hypermedia API is the way to go?
Yeah, I think, building an API on top of HTTP using, the principles of hypermedia and kind of the hypermedia constraint, or as some people kind of incorrectly say, HATEOAS, or like the hypermedia as the engine of application state.
I was just Googling that to bring it back up again because I couldn't remember how you say it and what it meant.
Yeah, I got part of that wrong. But yeah, it's basically like,
That was pretty good. Hypermedia as the engine of application state. Yeah, you got it right.
Oh, wow. I got it.
You drilled it. HATEOAS.
Yeah. And I think Roy Fielding brought it up once where he's just like, it's just called the hypermedia constraint. Like that's what it is. Like that's the proper way to refer to this. You don't need to do this other thing.
Right.
I think people kind of maybe they too directly interpreted what that would mean, and they didn't broaden it out enough. So I think that's a failing of the hypermedia community and world, which also kind of like I started to move away from them as well, because I was like, this is a little too much zealotry of like, no, everything must be hypermedia. And I'm like, eh.
Okay, so for us plebs like myself, because I just was Googling the term, and maybe a few of our listeners self-identify with me as pleb, what is HATEOAS? What does it mean as the application state, or whatever you said exactly? Like hypermedia as the engine of application state. What does that constraint mean? And then what were they trying to broaden it to from there?
So at a base level, hypermedia is really, I think it's kind of for like hypermedia controls, which means you have this base layer of media, which is, some type of document, some type of information, and then you add controls to that, which usually come in the form of links. So when you think of HTML, the hypermedia controls in HTML are like the anchor tag, the link tag, and like form tags, right?
Right.
And these give the application the ability to move the application to do things, to kind of navigate around. So with forms, you can send data to the server. And the idea behind the hypermedia constraint is that the server controls from the perspective of like what the client is allowed to do via hypermedia, and then the client chooses what to do via the hypermedia that was given by the server, right? So the server sends you links, you use those links to do things and move the application state forward, right? So it's like, oh, I give you a link to create an account, or I create a form to create an account. You fill out the form, you send that back to me. Now I have created an account, and the kind of little state engine of account creation kind of moves forward. based on those hypermedia controls that you were given, based on that form that you were able to fill out.
Right. So the API itself, the servers, they actually publish the things that you can do via hypermedia responses.
In the responses, yes.
In the response is the other things that you can do. And the idea behind this, I think, like the panacea or like the idea was like, okay, then you don't need a human at all in terms of like the client code can then just ingest that information and use it to navigate to the next page, for instance, or to allow, show what to do, the user what they can do, and then they hit the button and it knows where to go. It was like not exactly the way RESTful APIs are, though, because like we go and read the docs for the RESTful API, but like the idea was ideally you wouldn't have to even do that, right? As a client developer.
Yeah. So like the idea is, and this is where like, I mean, I've long since given up on this, but like the REST APIs that we're used to thinking about are really HTTP APIs. But I realized that like REST as a term has gotten lost, which is why I think a lot of us started calling them hypermedia APIs.
And REST stands for representational state transfer. I'm going back to my...
Yes, representational state transfer.
Pull that one out of the old dictionary there. Which means what? Representational state transfer. I mean, even that is a conundrum of a phrase, right?
Yeah. I guess the basic idea of that is that, I mean, I guess this kind of says it's like what's on the tin, right? You have a representation and you want to, move it to, you want to give it to somebody.
So that's a state transfer.
Yeah, is that you transfer that state to somebody else. And the state that you're transferring isn't like, I think this is in the paper, but there's this idea of like, there's the resource, and then there's the representation of that resource. And the thing that you're moving is the representation of it. So like, there's you, Jared, as a human, and then there's like your account on changelog, which represents you.
Right.
But when you transfer that state to the client, you're not transferring you as a human over it. You're transferring that representation of you over it. So that's like the idea of the representational state transfer. It's like, okay, I'm taking the representation and I'm moving it to somewhere else. I'm taking the state of that representation and moving it somewhere else.
Okay, moving it from the server to the client, not like changing the state of the thing.
Yes. And it also has like, REST also includes the ability for like the client to then change that state, right? To move it. You're like, oh, I got the representation. Now I can make some modifications, send it back to you, and that will change the state of that representation and potentially of the resource behind it within the server.
Okay, so what you were saying before I so rudely interrupted to get that clarity is that what we call REST or RESTful, meaning it has certain properties of REST, is the way I've just determined what RESTful means, is that they're not actually REST APIs, they're HTTP APIs.
Right.
Because of what do they fall short of that is not a representational state transfer?
They violate a lot of the actual components that Roy Fielding defined in his dissertation where he defined REST. The biggest one is obviously hypermedia. They are not based in hypermedia because you got to go read a thing to understand them. And there's a few other, I think that's definitely the biggest one of why they're not.
Okay. Why aren't we writing hypermedia? Like, what was the sticking point? Is it too hard? Is it not performant at scale? Like, why don't we do that? We don't do it.
I think because it wasn't the most basic thing we could do, right? It takes a little bit of thought and a little bit of extra writing in the beginning to actually build a hypermedia system, right? Because you have to have the server sending information to the client and you've got to structure that in some way. And then the client has to have a little bit more logic in it to be able to be like, oh, okay, like I understand what these links mean and I understand how to display them to the user and how the user can select them. But I think that the biggest thing is that in the early days, the only hypermedia format we really had was HTML, and to some degree you could get XML to do it. And we were missing a very big component that we sort of have now, which is the ability to define what things mean outside of the representation that you send back, right? So this is a kind of big component of hypermedia, is that you have the different representations. So you might have it rendered in JSON or XML or HTML or whatever. And then you have the actual definitions of things, which, you can pull from schema.org or friend of a friend or like a whole bunch of other places. That's like, okay, so when you see a field in an object with like the word's name, it means this thing specifically, right? It means, okay, it's a person and it's their first name, right? Or it's a person and it's their preferred name or whatever, like an actual structured way of being like, these are what these words mean. And we didn't really have a good way of conveying that information. And if you don't have a good way of conveying that information, what you wind up doing is you just wind up packing that into the representation that you send. Like this is, what we do in JSON APIs a lot. It's like, okay, I have a name field and it's like, okay, well, how do you know what that name field means? It's like, well, we just write it in some docs somewhere and then the client goes and looks. It's like, okay, this name field is like the full name of the person and we just kind of know this information. Whereas with, I don't know, proper hypermedia, but the hypermedia system, you would transfer that information by saying, here's a schema that I'm using to refer that of what all of these, fields mean. Use this schema when you're interpreting this. And the thing that you have to then have on both sides is that schema and keep track of that schema. But that schema is disconnected from the representation that you're sending. So you can change the representation, but still be sending the same information. And that's what gives you some of the flexibility that you get from hypermedia APIs that you do not get from REST APIs. This is why REST APIs run into the version problem that they tend to run into, because you can't change the name of something or even in some cases the location of something because it's hard-coded into the client. Hey, this string means this thing, or this location is where I find this stuff. Instead of the client saying, oh, the server sent me this, let me interpret it. Okay, this string is mapped to this internal string I know, so I can connect those things together and process this information.
So I'm here with Ian Withrow, VP of Product Management at Sentry. So Ian, you've got a developer-first application monitoring platform. It shows you what's slowed down to the line of code. That's very developer-friendly and is making performance monitoring actionable. What are you all doing that's new? What's novel there?
Traditionally, in errors, what's the strength of Sentry is we've taken not a stream of errors and said, hey, go look at this, like all these error codes that are flowing into your sets. We actually look at them, we try and fingerprint them and say, hey, we've actually grouped all these things. And then we give you everything you need within Sentry to go and solve that error and close that out. And that's, I think, driven tons of value for our users. And traditionally, if you look at performance, it's not that thing. It's looking at certain golden signals, setting up lots of alerts, maintaining those alerts, grooming those alerts, and then detecting them. And then maybe you have a war room and you try and look at traces, or maybe you realize, oh, it's this engineering team that owns it. And maybe they'll look at logs or whatever they have available. Performance is very rotated on detection and then isolating to where the problem may exist. And root causing is often an exercise left to the user. Good performance products provide a lot of context and details that an experienced engineer or DevOps professional can kind of parse and make sense of and try and get to a hypothesis of what went wrong. But it's not like that Sentry error experience where it's like, here's a stack trace, here's all the tags. Oh, we see it's like this particular segment of code, and Ian did the commit that changed that code. And do you want to fire a Jira issue and assign it to Ian? Like it's right. Not that crisp, kind of tight workflow that we have errors.
This is breadcrumbs.
Right. And we said, hey, maybe there's no reason why we couldn't do this for performance. Let's try.
Okay. So you took a swing. You tried. Describe to me how that trial works. If I go to my dashboard now and I enable APM on my application, what are the steps?
Largely because we kind of encourage you to go and set up transaction information when you set up Sentry. You probably, as a user, probably don't need to do much, but if you skip that step, you do need to configure to send that data in your SDK. And what happens is we start now looking at that information, and then when we see what we call a performance issue, we fingerprint that, and we put that into your issues feed, which is already where you're looking for error issues.
Right. It's not a separate inbox. This is the same inbox.
The same inbox, yeah. Now, we obviously give logical filters, and if you just want to look at those, we do that. And for newer users, sometimes we detect, hey, you've probably never seen this before. We can we do things because we know we build for mass market to bring your attention to it. But it's the same workflow that you have for errors today. So you don't have to learn something new to take advantage of these things. So you asked for the experiment. So last fall, we did the experiment, the first one, which we called N+1. And we didn't know how it was go, honestly. But people liked it. Like we kind of know people like it when they start tweeting and saying nice things about it. And so, it got traction.
Very cool. So if your team is looking for a developer-first APM tool to use, check out Sentry and use the code changelog when you sign up, and you're going to get the team plan for free for 3 months. Make sure you tell them we sent you because they love hearing from our listeners. Check them out at sentry.io. Again, Sentry.io. That's SENTRY.io.
So a little story about some more ancient history from me was that way back in the day, I did a rewrite of Groove Shark's client. So do you remember Groove Shark?
I do.
Before your time. Okay, cool. So Groove Shark was cool back in the day, and they had a lot of steam. This was an old music streaming app, for those who aren't aware, that was post-Napster, pre-Spotify, Apple Music, very much in like the iTunes days of like buying songs for 99 cents. And they were user-generated content, and they had a very beautiful Flash, like a very well-designed Flash-based player, and lots of music on there that people would upload and listen to. And they brought me in for reasons that's a whole nother story, to help them rewrite their client from the Flash version, which was their production one, to a new HTML5 player. This is when HTML5 first became a term. And so it was going to be all web technologies. And that was a fun, interesting project. And a lot of stuff didn't exist back then. So like this is pre any sort of JavaScript tooling beyond basics. So like I remember using a framework called JavaScript MVC, which was very loosely kind of recreating model view controller architecture that I was used to from Ruby on Rails in the web browser. And I cobbled together a bunch of stuff and wrote a bunch of custom code as well to actually put together one of the early single page apps that was like used by millions and not by, hundreds. But anyways, I say all that to say this. When I started working on that, I went to their lead backend dev. They flew me down to Gainesville, Florida. They were from Gainesville. And I got to sit in their offices for a few days and code on the early prototypes. And all I really liked was like RESTful APIs and stuff. And I just thought they were the bee's knees because I love the web and I love URLs and addresses, and like makes total sense to me that like you're just publishing the location of the objects, and like all that stuff just was sensical to me. Sensical is the opposite of nonsensical, Chris. In case I know you're a word guy. Keep up, Chris. Keep up. So I went to him and I'm like, hey man, I need your API docs. He's like, yeah, we don't have docs. No surprise there. And I'm like, oh, cool. Is it like a RESTful API or like, how do I? And he's like, no. He's like, it's a PHP app. And this guy coded the whole thing himself. Like he was very smart, but very much like the kind of guy who didn't have docs, and you had to go talk to him to find out how it worked. So not a shining example, but in some senses, very interesting. And he's like, no, there's a function and you call it, there's one endpoint. Here's the endpoint. He told it to me. He's like, then you put a question mark, and then you put, I can't remember what the parameter was, in the query string. And that's the name of the function you want to call. And then it was all JSON, I think. And that's how it works. And I'm like, this is terrible. And you know what? I wrote that thing in a few weeks, and it was so easy to use. Like he did give me a list of the different functions that you could, he had some docs. It's like, here's, he probably copy and pasted it out of his like PHP file that actually executed all of the stuff. He's like, here's like the 7 functions you can call, and then, just call them and you'll see what data comes back and you'll figure it out. And I was like, okay, I'm a big boy. I can do that. And I remember thinking, this is really terrible. And then I wrote that app, and it was actually not so bad, just to like have a single endpoint and just a I mean, it basically was a remote procedure call. Like it basically was.
Right.
I don't know why I told that story. Just as an example of like, sometimes simple is just okay, even at scale, I guess.
I feel like this is also like the place where the whole RESTful world went it just kind of got distracted by kind of the smaller parts of REST and not focus on the bigger parts, right? Like it doesn't do the hypermedia, but there's a lot of, because I remember like sitting through and watching talks and reading about how like, oh, you got to think about the hierarchy of all your resources and how they fit together and all of these like nice little URL hacking things and all the wildcard stuff, which is like not the part of REST that I think matters all that much, right? The whole like, oh, you have like, user/ID. And then if you want to like view, or if you want to like edit, you do like user/ID/edit or whatever, and all of that structuring. And I think that once I started actually reading about hypermedia and I realized that like that was actually not the thing that was supposed to matter in hypermedia, I think that's when I started to move away from the RESTful world. And I think that's the thing that really captured the RESTful world. I think it's like a very interesting, at least from what I can remember and from what I like the little research I've done, it's like a very interesting confluence of two different things that were happening at the same time, in the early 2010s of like, we were getting into the world of sharing URLs. So everybody was switching to using this whole clean URL thing. Like I remember being in Drupal and like enabling clean URLs and having these really pretty, like, oh, this looks so nice. And it's like so shareable. You copy it and you just send it to someone, which is really a way to work around a constraint. Because if you wanted to share something with someone, all you had was what was in the URL, right? You couldn't share things like headers with them or like bodies. So you had to put everything in the URL, and you wanted that URL to look nice, but you also wanted people in the browser to be able to hack those URLs, right? So if you had a thing that's like, oh, search, and then it had like the year, month, the day, and he'd be like, oh, I'll just remove the day, and then I can see everything from the month, or I can remove the month and see everything from the year. Like that type of power was really nice.
Yes.
And so I think when we started to develop these web APIs, the people that were kind of first doing it were like, oh, I want this to be super hackable. I want you to be able to go into curl and be able to just like figure out what it is and be able to do this without having to like document things a whole lot.
Right.
That I completely get. I'm like, yeah, no, that's a great way to bootstrap the whole thing. But I think we just got too caught on to that, and we didn't kind of evolve past that when it was like, okay, well, this was really just a hack. Now we're using advanced API clients that do have, they can do headers, they can do body, they can interpret the representations they get back and kind of not have to depend on the URL as like the main control of the whole thing. Because one of the things, and I believe Roy has said this quite often, is like the URL shouldn't matter, right? You should be able to encrypt all of the URLs to your application and have it still work fine, right? That's kind of one of the things about hypermedia, is that the actual addresses of things are irrelevant. And a lot of the ways, like, you don't know the actual the memory locations of the pointers in your code. You don't think about those things. You're like, oh, I have this name that I use. And it's like, oh, well, that name points to some memory, but I don't care what that memory is. I just have this handle that I'm going to use. Mm-hmm. And the way that REST APIs tend to work is that they are very much like, oh, I know this memory location. And if you change that memory location, my whole app is going to break, which makes everything very brittle. And we were never really able to push ourselves out of this. Like Go, in one of the recent releases, actually added support in the standard library for wildcards in URLs, which once again harkens back to that clean URL thing. It wasn't really necessary because we have query parameters, and you could always put the things that needed to be variable into the query parameters. But people are like, oh, that's ugly. And it's like, the machine's looking at it. The machine doesn't care.
Well, not always. So, I mean, what about humans? Like, I love passing URLs around, even to this day.
Yeah, but are you passing API URLs around?
Well, I would if they would allow it. I mean, sometimes I'll take an API URL and paste it into my browser and see if it renders. Yeah, not as much, obviously. So, maybe, we say web APIs, maybe we're just like fashioning them too much in the image of the web. Because, I mean, I think URLs and anchor tags and my ability even just to send you a Google search, because everything's in, even though that's stinking ugly, and I hate Amazon's URLs, right? Like, but they work. I can still pass it to you and you can render it.
Oh yeah.
Is a beauty of the web, and maybe we're just like, we just took that and we're like, it's going to make beautiful APIs, and maybe not.
Yeah, like once again, it was like a browser constraint that doesn't exist in API clients, and I don't think we ever shifted away from that to really rethink I think we just didn't have a sit down and a big rethink of like, oh, this thing is different from our browser. This thing has different constraints than our browser. Maybe we should try and broaden and use those constraints much. I also think too, like this is once again where it's like we didn't necessarily have the right tooling and we didn't make it easy for people. Because I think one of the things people often think is they like, oh, well, hypermedia sounds really cool. This ability to have this flexible application that, you know, the client can just keep working even when you change things on the back end and it's super flexible and it'll just send you stuff and you just render the stuff you have and you don't have to make big updates. But people are like, that's going to take so much more code than what I have now. But that's actually not true. I think Mike Amundsen, who's one of the kind of big hypermedia people and big API people, has for years been like, no, it actually takes less code on the client to implement a hypermedia API. And it's more flexible in the future. You can just add stuff to the back end and it'll just automatically appear in the front end without you having to do deploy or anything.
Because it's discoverable by the client itself.
Yeah, I think people have it in their head that it's going to require more effort, more work, when really it's just different work that you're going to be doing.
Okay. Are there any hypermedia APIs in the wild that you could point to?
I mean, GitHub tried with their HTTP API to make it hypermedia. I think a lot of people did make efforts to, and there's a lot of remnants of them hanging around. Like I think in GitHub's HTTP API, they still have headers you get back that tell you like, if it's a page of search results that say, here's the next, here's the previous, here's the current, like, excuse me, those are hypermedia controls. I think that it's kind of, you know, for various reasons, there's not a lot of them around anymore because I think a lot of people that did have hypermedia APIs shifted them to GraphQL APIs because that was the story that was sold, is like GraphQL is like the successor to hypermedia because hypermedia doesn't really work. So everybody should go use GraphQL, and all the front end folks were like, GraphQL is amazing and it's awesome. But I think part of that as well was because of the bad way we were writing hypermedia APIs, right? Maybe this was the chief complaint. And one of the big reasons why Facebook built GraphQL was that everything was kind of split up into those resources-based things. So it's like, oh, you can get like the user, but then you have to like go get their friends and go get so it was like these big chains of HTTP requests you were making. So you had to get each object, then do some processing, get the next object.
Right.
That problem has been solved in hypermedia for a long time of being like, oh, no, just give me this entire representation or give me like, you know, these parts of it. And, you know, having search parameters, like that stuff is built into some types. Like I believe it's built into collection JSON and some of the ways that you can do querying with it. But at that time, I think that was a very like not known thing. So the big advantage of GraphQL was I can make one HTTP request instead of making 10 or 20 or whatever to get this exact information I want. And I'm not getting all this extra information, which was really just the design of the hypermedia API you had was not a fit for what you were trying to do. So we needed to do some redesign. And I think people are like, well, I just want to do something to get something done because we have a problem.
Right. It also moves the decision-making process of what data is needed closer to the entity that needs it. So the developer who's actually developing that client, they're almost configuring the API to give them what they need and nothing else.
Right.
And they're the ones who have that knowledge versus saying, hey, backend team, can you modify this endpoint to also have this data along with it? Or can you put the location of the hypermedia URL in there so that the client can discover it? I'm not sure how it would work if we're actually doing hypermedia because obviously I've never seen it done properly. And then you have that whole process, which is just inefficiencies inside of an org, right? It's like, oh, we're waiting on backend for them to do this. And in the meantime, I'm not making any progress. And so that's why I said I think it was like Facebook problems being solved, plus very good demos and empowerment of front enders to just specify what they need inside the technology versus via a ticket in Jira.
I think part of this too is like a lack of proper design for our APIs. Like I've seen a lot of APIs and I think it's, you know, people are just like, oh, we need these objects to represent, to be put onto the front end. And there's not a lot of thought of like, well, what objects do we need in the future? Or what ways can we make this more flexible? Like I think too much of the time we don't think about flexibility when we're thinking about the APIs that we're trying to design. And we just try and tack flexibility on at the end and be like, okay, well, we'll just add it here. And that's like, you know, one of the things that GraphQL does give you a lot of, as you've mentioned, is a huge amount of flexibility for the people on the front end. But it's also very challenging for the backend to implement GraphQL. Like I've looked at it before. I was like, this is. So it's kind of like you've shifted the problem like now onto the backend folks, which I think why, there's, that thing you found for Postgres, which is just like, you know what? We're just going to dump our database onto the network and y'all can just, program it from the front end, which is not great, especially from a security perspective. I always dislike the idea of trying to encode access controls into SQL because challenging. But I think it was a real pain point for people and it needed solving. But I think we've also kind of swung back the other way now, where it's just kind of like, okay, well, now back end people are starting to struggle and trying to figure out like, how do I implement these things, especially when you start having huge numbers of APIs that you're then putting behind this GraphQL gateway, but your APIs are REST APIs because that's what developers like, backend developers. And then you have this GraphQL thing. And it's like I went through this type of thing at one of my previous jobs. And I was like, okay, this is just kind of a nightmare for everybody now.
Yeah, and I guess the ambition of GraphQL to be like you said, that front layer for like all kinds of data backends. I know like that's what the Gatsby team was working on for a long time, where it's just like as a front end, you just have GraphQL, and it could be like, your own application servers accessing your own database, or it could be like this other data source coming from whatever API over there that we're going to pull in and proxy and cache the crap out of, I'm sure of, and add that to our graph. And you can have just one big GraphQL API black box that you hit. And it's like, it's kind of like when you do a function call that hits the network versus one that, just does some math. It's like those functions should be different, right? Because they are fundamentally different in performance, like foundationally way different. And so like fronting a bunch of disparate API backends with one GraphQL thing that you're all calling, to me, I always felt like, well, that's a little too ambitious, but maybe I'm just not an ambitious guy.
There's definitely aspects of GraphQL that I like. Like I like the idea of having this ability, especially if you have graph-like data. I think GraphQL makes a lot of sense. It's like, okay, well, like this is literally a query language for graph-style data. Mm-hmm. I'm just not really convinced that most people have graph-style data, right? I'm not convinced that like this is like the structure that you really are aiming for, or that you have enough stuff. The kind of graph query language is what you want. This might be a place where I'm starting to become like a bit of an outlier too, because I feel similarly about SQL these days too, where I'm just like, I don't really know if SQL is the language that we should all be using for our databases, or if this is like the way we should be designing things. But I do recognize that as like, this is the thing that's popular. This is the thing that's, you can hire for. This is like, there's other reasons why people want to use these things.
Yeah, I think like a lot of new upstart database vendors who have had, again, ambitions and maybe audacity to eschew SQL and come up with something better / different / their own. Most of those, maybe MongoDB is the exception, most of those have fallen by the wayside or have not been able to get the pickup and eventually either say, yeah, you can now speak SQL to our database in addition to our custom language, or they just don't make it because of the mind share and the existing just dominance.
I think maybe this is also what like so many APIs look so similar to each other, is that like if you're going to build a database that operates like an SQL database, you should probably just use SQL with it, which is like the same way I feel about APIs, right? If you're going to build an API that's just going to return some JSON, I don't know, use JSON API. Or if you just want to use protocol buffers, use gRPC. Or if you have graph-like data, just use GraphQL. Like I think those things are okay to use in the small. I think where the problem comes in, and probably where like the whole it depends comes in, is like, how do we as an industry move to build new things if everybody is always just kind of regressing down to this mean here, going back to the homeostasis point of like, oh, well, I just want to use JSON. I just want to use an SQL-like structure for things instead of trying to, maybe do something a little different.
I have an answer for that you're going to love.
Okay.
The answer for that is large language models.
Oh, God.
No, hear me out. So you come up with something better, foundationally better, but different. And you also provide some sort of pre-trained or fine-tuned model that fits right in with developer tooling. I mean, no one's writing SQL anymore, Chris. You're the only one left. And even myself, who am relatively reserved when it comes to GPT tooling, I'm not writing SQL from scratch. I'll go there first, unless it's like select star from this or that, if it's a little bit beyond basics, there's like one or two joins in there. Like I just don't care anymore. I don't have time. I will ask the thing and get it back. And so if it returned something that wasn't SQL, but still accomplished my goal, happened to be this new thing that was better in every way, I don't care anymore. I don't need to know.
Yeah. I guess the issue at hand is that like there's a shift in the mindset of the whole stack that I think kind of needs to happen for us to build new stuff. Like I'm actually like actively going through this because I made the decision mostly when I started looking at the prices of hosting like Postgres. I was like, I don't want to pay this right now. Like I guess when you're a company, it's just like, okay, this is a little bit of expense, but I'm just like getting a high availability Postgres server is like, $50 a month, $100 a month. I'm like, that's some money I'd rather not spend.
Sure.
So I'm going on this adventure of like actually trying to like from the base level components, like build up a kind of new age style database and kind of build, APIs just directly on top of HTTP. And it just looks fundamentally different from how so much of the stuff that we usually build looks. And I think like, I don't know if you can just kind of swap out a part of it. It feels like you have to swap out the whole way you think about things.
You gonna publish any of this code or?
Yeah. I'm gonna, or at least publish my thoughts behind it, right? Like that's kind of the idea of what I'm doing now is like the whole idea of like the learning in public that I want to do is like sit down and actually go through all of this and document my journey, then put it out there, and then also write about, hey, this is how you can do it yourself. Because
cool.
Like the thing that I'm trying to build now is just like a little based on CRDTs, like, hey, cool, like let's see if we can build some database out of these lower level components and see what we come up with.
So these words you're going to write about this whole new style of doing things, can I use them to fine tune my data model? Because if I can, then I'm set. I'm ready to adopt. I'm ready to go to the new place.
Yeah, I mean, in a way, like that's part of the goal is to like kind of give people access to information that might have been harder to find before. I think that's like the big thing when it comes to hypermedia APIs, right? Like I went through this years ago when I was first really getting into them, and I designed a system that was specifically hypermedia API based. And my coworkers at first were like, we don't know about this. Why don't we just write it regularly? And then I like, no, like just try this thing out. And then they tried it out and they're like, oh, wow, no, like this is actually really nice to work with. Like, I really like this. Like these things that we're doing are like, it's so much more flexibility. It's so much less code overall. We can evolve it so much easier. So I think a big portion of the problem is that like, there's just not enough content out there for people to learn about how to do this stuff.
Yeah.
You want to use GraphQL, you want to use gRPC, there are tons of resources to learn that. But if you want to learn how to build even just an API based on HTTP, it's like, I don't know, go read the HTTP specifications. It's like, that's not a good experience for people.
So yeah, hypermedia APIs need some marketers. They need some people to, like Roy Fielding, he should have wrote one. Did he write one?
A hypermedia API?
I mean, what he defined. Like, was there sample code?
I mean, like he defined REST, right? So he defined like what web browsers use.
Did he write a REST API that we could all look at? And
I mean, he wasn't specifically talking about APIs. He was just talking about like REST is just in general the thing. Hypermedia APIs are applying REST principles to APIs.
REST is a general thing for life, or for what? What was the context here? Pass me a context object.
Just for applications, right? It's like that's how the web works. The web is REST, right? Fundamentally, the entire web works on REST, right? And this is the thing I'd always bring up before of just like, people probably wouldn't use the web if you had to get a book in the mail that you'd look up and see which URL you need to go to log into Facebook and which URL you need to go to go do this thing. And, which URL you need to go to do a Google search. Like people probably wouldn't like that too much, especially if then Facebook updated its login page to be somewhere else. And all of a sudden you can't log in because you got to go get the new book in the mail, right? That would suck.
Well, the web has a different thing. So the web has Google, and Google, I guess, was the HATEOAS, right? So Google is where you go to get your index of things. Like the number one search on Google for many years was Facebook.com. People would type Facebook.com into Google search, and then they click the first link to get to Facebook.com.
Yeah.
And so that kind of is the phone book, isn't it?
The only reason that Google works is because the web is built on the hypermedia principle, right?
Because it can crawl.
because you can crawl, right? That's one of the things that you can do because the controls are in there. So everywhere that you can go, all of the actions you can take are in the response you get back. So you crawl a root level domain, and then you can be like, oh, here are all the links in the page. I'm going to follow all those. And then the links in the page I get back from there, I follow all those. And the links in the page I get, and it's just like a continuous thing. And that's how you can crawl the whole web. You can't crawl a REST API. That's not a thing. The responses you get back, they're dead ends. Every single one of them is a dead end. You have to know the specifics of the API, know the specific structure, all of that. So like literally, the web would not work as it does today. It wouldn't function, wouldn't exist as it does today if it weren't for the hypermedia controls that are embedded into it. We just don't have them. And that's why APIs aren't discoverable. That's why we can't crawl an API to find out what are all of the endpoints, what are all the things I can do with this API.
So the folks who came earlier, like after Roy Fielding, but before you and me here today, that thought, okay, this is a good idea. The HATEOAS folks, the ones who say like RESTful APIs aren't HATEOAS, and they want to point that out. Where are their sample apps? Where are their API? Like, shouldn't there be the book and the sample app and the example? Like, why you said GitHub tried? I'm just playing a little devil's advocate here, Chris. GitHub tried, but did they fail? I mean,
there were lots of efforts to do so, but I think like there were just missing pieces to translate what we had with web browsers into APIs, right? As I mentioned, right? Like in order to make a hypermedia client work, you need to have some way of defining the schema of the things that are going to come back. So you have to have a way of defining what things are. Because like on the web, humans do that, right? You see words and you're like, oh, that word means that thing. Oh, sign in, log in, whatever. These are all things that mean like, oh, I can put some information in and get access to my account. We all know what that means, but computers don't understand anything. So we have to tell them, hey, these are
Have you heard of LLMs, Chris? Have you heard of LLMs?
Listen, Jared.
I'm just trolling at this point. Keep going.
So like with a client, we have to give it some reference point. So it says like, oh, okay. So even if the text says sign in or log in or whatever, that really means authenticate. So we have to give it something that like basically an opaque string that means like, hey, this is the authenticate thing. Go look for the thing that's referenced in this response to see what the authenticate thing is, and then present that to the user on screen. And I still think today we don't have really good tools for actually defining that information to give to people that are building clients so they can build their clients against that. Because that's still the information that you need to have at the end of the day. You need to have the schema of something to understand what it is you can do. The thing that really hypermedia allows you to do is change the representations that you're sending back or move the representations to other places so that you can evolve one side without having to evolve the other. And I think that's the thing that I think got lost in that entire stretch there. I think people got enamored with so many of the other things that they forgot that it's about like, we have to be able to define things. We have to give people something to define with, and then they can do all this nice stuff with different representations and being able to evolve things and move things and all of that, right? Like, oh, I want a new version of my API. Well, if, when the client makes the request, it sends a, hey, this is the schema that I can speak. Then the server can be like, oh, actually, if you want to speak this schema, go make a request to this other URL instead of the one that you sent to. And it's like, okay, I'll just follow that redirect. Okay, now it's this. And now the server's like, okay, now I can talk this older protocol to you or whatever. Or it's like, oh, there's actually more newer information, but since you only speak this version of the schema, I'm only going to send you this other information back. Which once again is like, a lot of it comes down to flexibility. Like it gives you the ability to change things independent of the other thing that's operating. And I think the biggest reason why this didn't catch on is that in the beginning, people never think that they're going to have to change their APIs. People think that they're not going to have to evolve it. They think, oh no, this will be fine. Or I'll just add a version in the URL and that'll be great. But they don't think about, well, how do you get all of the old clients off? How do you, like, there's not a lot of forethought that gets put into that, mostly because a lot of the time we're just trying to get something built, trying to get something out the door.
Yeah.
And there's not enough of a push to be like, no, we shouldn't be doing that. We should really find a way to make sure that we do think about evolvability and that we as an industry say, no, it's important to think about evolvability.
They're just trying to get something out the door. So here comes the world's first, it depends, hypothetical. This is a test for you, Chris. I'm going to give you a hypothetical, and you're going to have to apply your knowledge to give an answer. So,
Okay.
you are a senior engineer, tech lead, I don't know what you want to call yourself, at a startup that has raised Series C. Do they do Series C?
Yeah.
Yeah, they do. So you've had some success, at least. You have some users. You have production things. And you are tasked with, we have a website. It's a web-based company, and they want a public web API.
Okay.
And they want you to lead up the charge today. And you just said you just want to get stuff out the door. And this is the situation. You do want to get stuff out the door. You don't want to go back and reinvent everything from the ground up.
Right.
What do you do? Where do you go? What do you build? You can ask more questions and I'll give you more fake information.
Yeah. So like, I guess who is like, are we as a company going to build API clients for people, or are we just going to be like, here's the API and go use it to your heart's extent?
It will be a public API consumable by anybody who has whatever permissions we decide. So it's not just yourselves consuming it, no.
Right. Okay.
You already have a mobile app that also consumes a private API.
Okay.
That threw a wrench. Or helped. Let's see, that helped.
I think if it's like an API that like kind of anybody out there is going to consume, I'd probably just, pragmatically speaking, build something that uses open API and that kind of RESTful structure where you can like generate some clients for some people and focus on documenting that very well and laying everything out there. If it's an API that's going to be specifically targeted at people building front ends, then I think it would be useful to consider something like GraphQL, because that community is so familiar with that type of thing. And if our data model lends itself to something that's going to be GraphQL friendly, like if it's a read heavy API, I think it's okay. If it's going to be a write heavy API, I don't think GraphQL makes as much sense. I think writing with GraphQL is kind of wonky. But I think the kind of broad thing is, as much as I do not like OpenAPI and Swagger, I think that pragmatically, you're trying to get something out the door. I think that's the place that you start to get something out, to really see if people will use this thing. And if they do start using it and it becomes good, I think at that point, right after that, once people are like, okay, this is good, we're getting user, we're getting traction, that's when you start planning your API strategy and you start saying, okay, do we want to commit to OpenAPI for the long term? Do we want to explore other options? Or do we want to build something that can actually handle multiple different API front ends? Because I think the answer that I would push toward is building a platform that can support pretty much any of the API technologies that are out there. Because, you might start with OpenAPI and you might be like, oh, wow, people are building a lot of JavaScript front ends with this. It'd probably be a good idea to support some GraphQL as well and being able to add that in after the fact. So, build a quick thing to see if it gets traction. And then after that, start building out a better strategy to make sure that you stay on board with things and make sure that as you're developing the backend as well, you're developing with the idea that it won't just be OpenAPI, it won't just be GraphQL, or just won't be this one thing.
Okay. So give us the elevator pitch or the quick explainer on OpenAPI, Spec, and Swagger, why you would pick those to get going. And then also, as a follow-up, why you don't like those.
I mean, I'd pick them to get going because I think as far as, when I think of an API, what I usually think of is someone who's writing some sort of backend language, whether that's like Ruby, Node, Python, Go, Java, whatever. And those are not things that I think lend themselves to, like, say, a GraphQL. I probably don't want to use GraphQL from Go or Java. And I don't really like the idea of having, say, a gRPC API kind of exposed out there, because then I'm dealing with like having to ship people protocol buffer file. No, thank you. And I think between, say, JSON API and Open API, I would say Open API gives you the most flexibility with representations, right? If you do want to start supporting Protobus in the future or XML or something else, Open API will allow you to do that. So that makes sense. And, as much as I hate YAML, it's fine to write out an Open API spec, and you can also like generate it from your code and all of that if you want. The reason I don't like Open API is because I think the main thing it gives you is pretty docs. And I don't think it encourages you to write comprehensive API documentation, right? I've tried to use many open API specs for things, and the documentation is just crap. It's just so sparse. It doesn't really give you all of the information that you need. Even the models are just like, hey, it's just like assumed you already know everything. It's like, if I already know everything, I wouldn't need to be looking at your documentation. So I think it allows people to have the illusion that they've documented their API without actually having documented their API. So that's why I don't like it. And I mean, I've been at a couple places where you wind up with like 3,000 line long YAML files to define an API. And that's just not reasonable to maintain in any way, shape, or form.
That's not reasonable.
So I think that's why it's like, yeah, I'd use it, but that's also when like I'd use it and then I'd try to immediately figure out like, how do we make sure that this isn't the thing we're stuck with forever?
Good stuff. Good stuff. Well, I am tempted to end it here, even though we didn't plumb anywhere near the depths of your outline, which I told you was going to happen. There's just too much good stuff to dive into here.
I was writing this outline and I was like, oh man, I'm like, is this going to be enough stuff? And it's like, oh.
Right? Nah, there's always room for more. Anything from your outline or from your thoughts? I know you had ABIs on the brain. Anything that you'd want to just shove in here at the end just to get them on the air before we're done with this topic?
The thing I had at the very end where I'm thinking that HTTP is more like an ABI definition than it is an API definition, which I think is a kind of novel thought that I've definitely been gravitating toward.
Okay, why do you think that?
Right. So, the point of an ABI is, or like the way that we define APIs within, say, like an operating system context or whatever, is that they really define like the calling convention. So it's like, okay, you're in assembly, you want to make a call to this function. How do you do that, right? Do you put things on the stack? Do you put things in registers? If you're putting on the stack, what order you put them on the stack? All of that, and then you got to do the jump into the function. So it really defines the mechanics of how that function call happens. And I think HTTP gives you that same sort of base layer of like, please define your mechanics of how you would like to actually make this invocation happen. One of the things that I think about a lot is how a lot of the time people try and complete everything they want to do in a single HTTP request, right? They like make a request and they expect that request to be held until the result is available and send the result back. And that is not the only option, right? There's an option where you can make a request and then you get immediately back or very quickly back a 202 accepted that has a location of where you can go get the result. And then you can go short poll, long poll, whatever, go grab your results when it's ready. And then, the system can be like, hey, it's not ready yet. This is an estimated time we think it'll be ready. And that's a calling convention level thing because it like in your library that's making the API call, it doesn't have to expose that it made 2 HTTP requests versus making one that was just long polled. It can just hide that from you. So from the caller perspective, both look the same. But from the implementation perspective, it can potentially give you more information. It can surface more information to ops. It allows you, especially if you do like the 202 accepted thing, it allows your server to do some like load shedding in a way where it's like, I don't have to hold open all of these connections. I can close a bunch of them and be like, here, go get this information from this other place that might be like another pool of servers or something that's ready to handle long polls or whatever. It just gives you so much more flexibility with how you can design your architecture, but you can only do that if you've actually thought about HTTP as this lower level calling convention-esque thing. Because if you don't, and you kind of just build your libraries and everything as if it's just everything's going to get done in one HTTP request, then you're kind of stuck with that. And there's a whole bunch of pieces of functionality within HTTP that allow you to do this. Like one of them that I stumbled upon is the prefer header, which is a way for clients to communicate their preferences to the server of what they'd like. And one of those is called wait, and it's a value that has some seconds in it. And that value says how long the client is kind of expecting to wait for a response. So, if you want to have the ability to do both like long polled responses and, accept, 202 accept responses, you can enable both in the server. And then when the client sends a request, it just says, maybe it says the value will wait to 0 to be like, please just give me an accept back. Or it might put it at like 300 to be like, let's long poll this. I will wait until you're ready. And when you design your APIs like this, when you kind of have this lower level substrate, you gain so much more flexibility in what you can do as far as evolvability of your system and the architecture of what you have, right? As I said, like maybe in the beginning, you start with one API server that's just handling everything, but then you're like, oh, I can't handle everything, but we can do some long polling result weighting. We can build some really lightweight servers that are really well optimized to do long polling and are very efficient with their resources. And then we'll have a whole bunch of those. So then when we have too much load coming into the main API server, then we start doing that load shedding, sending back 202 accepteds to push people over to the other servers. And then we have an event system that sends the responses to that other pool of servers that then sends the response back to the client, right? It gives you more options for how you grow your APIs over time. So you're not kind of stuck with what you did in the beginning.
I like that thought. I'll have to put more thought into that thought. I think my immediate thought, if I could just keep saying the word thought, is that there's a lot more to HTTP in terms of functionality and availability of things that we're probably not collectively leveraging or using in ways that would be quite beneficial if we, I guess, maybe even just knew the protocol better.
Yeah.
And when I say we, I'm just kind of talking about myself in the plural. And probably there's other people that are like me. Hopefully, I'm not the only one who doesn't understand HTTP. Because I'm learning stuff right here live, Chris. I didn't know about those things.
Yeah. I mean, some of this is stuff that I've like, once again, I'm like building out stuff on my own now. So it's like, okay, I'm going to take a little bit of time to actually figure out how to do this right. Like the way I found this prefer header was I was actually trying to build live reload or live refresh for the website that I'm working on. And I wanted to have it like, you know, it's all served via a Go application. And I couldn't use a lot of the traditional methods like a WebSocket connection or whatever, because the server would get recompiled and restarted. And I was like, okay, well, how can I make this work? And I figured out like, okay, well, I can have like a long pulled connection. And at first I was like, oh, we'll just like send back a special header that has like the version of the document. And when I make a new version, then it'll go do that. And then I was like, oh, wait, there's e-tags, there's entity tags in HTTP that's literally built for this. And I plugged that in and it just started working. And then I was like, okay, well, how do I do this long pull? How do I indicate to a server that I'd like to do a long pull besides just being like, this thing does a long pull or do like a query parameter long pull? And that's why I went hunting and I found the prefer header. I'm like, oh, okay. So I can have the client just say, if the client specifies a value above this much, then it long pulls. If it doesn't, then I do a short pull, return the response immediately, which means I get to use the same endpoint for the initial load to go get the e-tag, because in the browser, like when you load the page for the first time, you don't have the e-tag, so you got to go get it. So you're like, okay, I send it with a weight of 0, it gives me it back immediately, and then I go turn around and do a weight of 300, so it's just long pulls. And then when there's a change, it's just like it just responds back immediately with the, hey, there's a change. Like I think it's like a 2.0, whatever the no content one, 2.04 no content, being like, hey, there's new content here. Or after the long poll lapses, it just gives back like a not modified. And it turns out all of that stuff just works with the browser automatically, which is just beautiful, because then I can go in and like, I do that special trick with CSS where you like remove the DOM node from the DOM and then put it back to like refresh a style sheet. Mm-hmm. And it's looking at e-tags as well. So it just handles everything and it's just all the lines perfectly. And I was like, oh, this is really elegant. And it took me some time sitting down and looking at HTTP to be like, where is all of this stuff?
Right.
But it turned out to be all there. And I was like, I now have some special bespoke thing that I'm doing.
That's cool. So my last question for you is, what is your favorite resource on HTTP and why is it ChatGPT? I know where you're learning this stuff, Chris. I know where you're really learning it all.
Yeah, not ChatGPT. That is for sure. I know it's this is a very me answer.
You read the spec.
From reading the specs. Yeah, it's from reading the standards.
I had a feeling you might say that.
They're very well written. They're very well written standards. The thing I find a lot is there's a lot of bad information out there, which I assume also kind of trickles its way into ChatGPT, because ChatGPT just pulls from, the web, and the web just has lots of wrong and old information on it. So I think that, going and just reading the specifications is a good place to start. And I also think that one of the things I would love it if we as an industry could do is be a little bit more experimental with things and try some things out. Like one of the things I don't like about GraphQL is that it uses post for everything. And it makes sense why it uses post for everything, because we don't have an idempotent retrieval method in HTTP that includes a body, right? Neither head nor get allow you to have a body. Well, actually, get the body is undefined. So technically you could do it, but a whole bunch of things might break if you do. So I get starting off using post, but when this was kind of realized, the IETF, like the committee within the IETF that does HTTP, was like, hey, we have a missing method here. Maybe we should make one. So it started off being called search, and then I changed it to being called query, and it's literally just a get with a body. And that effort appears to have kind of stalled out. Part of the reason for that is because, like, you know, there isn't a lot of support behind it, pushing it. But I feel like, you know, if the GraphQL folks had been like, hey, we got to use this post thing for right now because it's what we have. But what we really want is get with a body. So let's go to the IETF and let's get with a body specified and put into the standard so that we can then use it for the thing that we want, so we can evolve this, you know, these standards forward. And I feel like that's what we should be doing with more of these things. And I think that would make everything overall a bit better. And that's one of my gripes with a lot of these technologies that are just kind of not using HTTP well because it doesn't fit their need, either because they don't know how to make it fit their need or because it literally, like in the case of GraphQL, does not have a specified way to fit their need. They're building the thing, but they're not going back and helping to repair that and fix that. So that's the thing that I would really like people to, and for people to just be a little bit more exploratory and be like, I don't know, make up your own headers, make up your own methods, make up your own stuff, see if it works for you internally, maybe even try a little bit externally and have some fallbacks, like the good old, you know, you in HTML, you can't use, you know, put or delete. So it's like, oh, well, we'll use post for this. We'll accept it over post. But if you want to use delete, you can use delete and it's semantically better. So like finding ways to move that, because that's really how we move the whole, like, the platforms forward. Like, this is the big thing the web platform does, where they like find ways to slowly add things with different types of trials and different types of shims and all of that. And I feel like we should be doing that in this API space as well, of trying to just move everything forward so that we can just have more stuff built into the platform as a whole.
Very well said. Well, to our listener, if you enjoyed this conversation, which if you didn't, you must be a glutton for punishment because you're still listening to it. It's just weird. But you're hoping for a Pound to Find this week because you heard me say on Changelog News that Pound to Find was coming up next. Well, it is coming up. It's just not coming up next. It's coming up now. It's coming up next week. So fingers crossed, of course. Things do change, but we plan on playing that game next week. And happy to provide this It Depends conversation with you, Chris, this week. I had a lot of fun, lots to chew on from here. We'll try to link up some things in the chat, or we'll just put a link to ChatGPT in the show notes so you can go ask it what we all talked about. Connect with Chris on gotime.fm. Anywhere else that you like to be contacted, email?
I'm like pretty much everywhere. Like Scriptable is my handle.
Scriptable.
So I'm still on like X. I guess I'm on Blue Sky now. I am actively, as I said, working on website, which will hopefully be rolled out in the near future. Trying to do some interesting things. I want to build an activity pub server, so lots of fun stuff. But
nice.
That's not there yet. So for right now, definitely, you know, still on X, still on, I'm on Blue Sky, and obviously Go Time.
There you go. All right, that's all for this week. If you like these It Depenses, let us know, because I respond positively to positive feedback, and I'll do more. If you don't like, just be quiet. Just don't say anything, and I won't do them anymore. But that's all for now. We'll talk to you all next time. Bye, friends. I went back and found that old blog post, the tech behind the new Groove Shark, written in December of 2010. That was a trip down memory lane. Maybe you'll remember some of these open source projects from back in the day. jQuery UI, SlickGrid, store.js, _.js, Clojure compiler. Remember that one? Good times, good times. I'll add it to the show notes just in case you're curious. We are scheduled to record and ship Pound to Find next week, and that's it for Changelog and Friends in 2023. We always take a couple weeks off at the end of the year to relax and refresh for the next one. Which reminds me, if you're making a year-end wrap-up of your favorite things, and if the changelog happens to be one of those things, let us know about it. We love reading about what our community members are into. You can do that in our free community Slack by signing up at changelog.com/community, or on X, we're at changelog, or on the Fediverse, we're changelog at changelog.social. Thanks once again to our partners, Fastly.com, Fly.io, and Typesense.org, and to our Beat Freak in residence, Breakmaster Cylinder. Speaking of BMC, we have a couple more Changelog Beats albums in the works. Stay tuned for those. Next week on the Changelog, News on Monday, our second and final All Things Open anthology on Wednesday, and we play that Pound to Find game on Friday. Have a great weekend. Share Changelog with your friends who might dig it, and let's talk again real soon.